The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. Okay, I finally made it through that. So that's not the right one. Hang on here. Boy, it's going to be one of those days, huh? Okay, today we're going to cover section 8.9 and the assignment tonight will be 8.9 in the chapter review. Tomorrow we'll have a review session with a test on Monday. But first, let's take a look at a question that came in by email. This is from section 8.5, number 16. And the problem says this: solve the equation, and we have 19 minus the absolute value of 12x plus 12 equals 19. Okay, so we have an equation with an absolute value on the left side of the equation, but there's some other stuff as well. There's a 19 and a minus sign, so we need to get rid of all that. So the first thing we're going to do is subtract 19 from both sides of the equation. That gives us negative the absolute value of 12x plus 12 equals 0. We still need to get rid of that negative sign. Well, that's the same thing as having like negative 1 times that absolute value. So we'll divide both sides by negative 1, which then gives us the absolute value of 12x plus 12 equals 0. As we talked about yesterday, if you have an absolute value equal to 0, there's only going to be one unique equation. So that would be 12x plus 12 equals 0, because equal to the opposite of 0 would be the same thing. Solving this equation for x, we'll subtract 12 from both sides. 12x equals negative 12. Divide both sides by 12, and we get x equals negative 1. Let's put that back into the original equation right there. So we get the following: 19 minus the absolute value of 12 times negative 1 plus 12 equals 19. Inside the absolute value bars, 12 times negative 1 is negative 12. Negative 12 plus 12 is 0. So we get 19 minus the absolute value of 0 is 0. So we end up with 19 equals 19. So it checks. That is the one and only solution. Any questions on that before we go on to another problem? All right. Do you have any questions? Anybody from section 8.5 before we go on to section 8.9?
Problem number, let's see, 21.
21. Okay. Just a second here. Do you want to just read it to me? Have you got it there? Or do you want me to look it up?
Yes, please.
Okay. All right. Let's see here. Hang on. Give me a minute. Okay. Let's see. No, must be the other one. Okay. Here we go. And 8.5. Which one was it?
21.
21. And I see you've got the right answer, but I suspect you still have some questions about it. Okay, not a problem. So this is 8.5, number 21. It says solve the equation. We have 13 over 10 equals the absolute value of x over 2 minus 4x over 5. Okay. So we have an absolute value on the right side of the equation. It's isolated. There's nothing else besides that. I'm going to just flip this whole thing around because I like to have my absolute value on the left side of the equation. So what we would end up with, we'd have what's inside equals what's outside, or what's inside equals the opposite of what's outside. So those are the two scenarios. Okay. On the left equation, I'm going to clear the fractions by multiplying both sides of the equation by the LCD, which is 10. You okay with that? Where I got the 10? Okay. So then distributing, I'm going to get 10 times x over 2 minus 10 times 4x over 5 equals 10 times 13 over 10. Going through and reducing, 10 over 2 is 5 over 1, so I get 5x. 10 over 5 is 2 over 1, so I get minus 8x. And 10 over 1 times, or what, 10 over 10 reduces down to 1 over 1, and I get 13. Okay, so far so good?
Yes.
All right, combining like terms on the left side of the equation, negative 3x equals 13. Divide both sides by negative 13, x equals negative 13 thirds. So there's one potential solution. Go on and take a look at the second equation. Again, I'm going to multiply both sides by the LCD, which is 10. Distributing, I'm going to get 10 times x over 2 minus 10 times 4x over 5 equals 10 times negative 13 tenths. Reducing, 10 over 2 is 5 over 1. I get 5x. 10 over 5 is 2 over 1 minus 8x. 10 over 10 is 1 over 1 equals negative 13. 5x minus 8x is negative 3x equals negative 13. Divide by negative 3 and x equals 13 thirds. So I have those two solutions. Do you want me to go ahead and check my work, or are you good to go?
No, it's fine.
Okay, so those are the two solutions, and it turns out if we check them, they both check. All right, any
Okay,
other
thank you.
questions? Anything else, anybody? All right, we'll go on to section 8.9, which is on the topic of variation. Okay, and there are three kinds of variation that we're going to look at today. Let's see here. I want to get that out of the way. Move this over here. And the first kind is called direct variation. A general form for that is y equals kx. X and y are the variables. K is what we call the variation constant. And what's going to happen in many of these problems is we're going to have a formula that has k in it. They will give us information allowing us to determine what k is. Then we'll put that value in the place of k and go from there. All right, now with direct variation, as x increases, y increases. As x decreases, y decreases. So they go up together or down together. In fact, direct variation, y equals kx, very much like y equals mx plus b, where b is just 0. Okay, so let's take a look at an example of direct variation. All right, we have this problem. It says free fall. An object in free fall. So basically we've got this object that's been dropped and it's just falling. Okay. An object in free fall travels a distance s. So s is going to be distance that varies directly as the square of time t. So t is going to equal time. If an object falls 1,024 feet, so the distance is in feet, how far will it fall? Oh, in 8 seconds, the time in seconds. How far will it fall in 10 seconds? Okay, so we've got S, which stands for the distance in feet, and T stands for time in seconds. Now let me read it again. It says, an object in free fall travels a distance S that varies directly to the square of time T. So S equals KT squared. Now, notice I inserted K there, the variation constant, and it wasn't even mentioned in the story problem. In fact, in most cases, it's not mentioned, but we have to just remember that it's in each of these three formulas we're going to look at. So the distance varies directly as the square of the time. All right, so there's our direct variation formula. Now it says, if an object falls 1,024 feet, so that would be S, in 8 seconds, 8 would be T, how far will it fall in 10 seconds? Well, this initial information, the 100 or the 1,024 feet and the 8 seconds, will allow us to determine what K is. 1,024 equals, let's see here, 8 squared would be 64, so I get 64 times K. I'm going to divide both sides of the equation by 64. I'll go to my handy dandy calculator. 1,024 divided by 64, K equals 16. So now I'm going to take this information and plug it in right there. So now my equation becomes S equals 16T squared. So I took the initial information to determine what K was, put that value in for K, and now I have a follow-up question. It says, how far will it fall? So that's S in 10 seconds. I want to warn you, the most common mistake that is made in these problems is when you have a situation like this where T is squared, make sure that T is squared the whole time. Don't drop that exponent off of there, okay? All right, so now I've got S equals 16 times 10 squared is 100, which would be 1,600 or 1,600, and that is feet. So the distance that it would fall would be 1,600 feet. Any questions about this example? All right. Next kind of variation is called inverse. Variation. And a general form of that is y equals k divided by x. So now k again is present. It's always there. It's always on top. X, the variable on the right, is down underneath. Okay. With inverse variation, as one variable increases, the other one decreases. Or as one variable decreases, the other one increases. So unlike direct variation that goes up together or down together, inverse variation, one goes up, the other goes down, one goes down, the other goes up. An example of that might be, I know under present condition, you probably don't do this on a regular basis, but are any of you coffee or latte drinkers where when school was in classrooms, maybe every day or a couple times a week, you'd stop and get a latte somewhere? Anybody? Nobody? No coffee drinkers? Okay. All right. Well, then I'll just make up some stuff here that'll fit the situation. I don't drink coffee, but let's just say I do. And let's say that, you know, I spend $5 on a latte, let's say 3 times a week. Okay. So $5 3 times a week. Okay. Now, if the price went up to $6, chances are I wouldn't keep buying 3 of them. Maybe if it went up to $6, I'd only get 2 times a week. What if it was like $8? Okay, well, maybe I'd only get 1 a week. So what's happening is the price is going up, the amount that I'm willing to purchase is going down. Let's go the other way. Let's say that, okay, let's go back to $5 3 times. Let's say it was $3. Well, then I'd probably buy like one every day or one every school day, 5 times a week. Let's say it was $1. Wow, I'd probably go 7 times. So again, if there's something that you like to consume or whatever, if the price goes up, the amount you're willing to buy generally goes down. If the price goes down, the amount you're willing to buy generally goes up. Does that make sense? So as one goes up, the other goes down. As one goes down, the other goes up. That's sort of how inverse, variation works. All right, let's take a look at an example of inverse variation. Let's see here. Here we go. It says organ pipes, like a big pipe organ that you might see in a church. The frequency of vibration of air in an organ pipe varies inversely to the length of the pipe. If a pipe 2 feet long vibrates 256 times per second, how many times per second will a 6-foot pipe vibrate? All right, so what do we got? We've got frequency of vibration. So F is going to be, we'll say, frequency of vibration. Inverse, and it says inversely proportional. This book likes to use the word variation and proportion kind of interchangeably, but it varies inversely to the length of the pipe. So L is going to be the length of the pipe. So F is the frequency of vibrations in the pipe, and L is the length of the pipe. Okay? So again, the frequency of vibration of air in an organ pipe, so that's F, varies inversely to the length of the pipe. Again, notice K is there. It didn't get mentioned, but it's there. It's always on top. Since we're dealing with inverse variation, L is on the bottom. Okay? So we established what our variables are, what the formula looks like. Now, if a pipe 2 feet long vibrates 256 times, how many times per second, or I should say 256 times per second, how many times per second will the 6-foot pipe vibrate? All right, so before I can answer that follow-up question, I need to determine K. So to solve for K, I'll multiply both sides of this equation by 2. 512 equals K. So now I'm going to take this and put it up there. So my formula looks like this. F equals 512 divided by L. So again, I established what my variables were. I wrote the formula. I used information to determine the variation constant K. I put that number in. Now we have a follow-up question that says, how many times per second will a 6-foot pipe vibrate? So the frequency of a 6-foot pipe. Once again, going to my calculator, 512 divided by 6. And what I get is 85.3 repeating on and on and on. Now, there's a tendency for students to round that off, but instead we should keep it exact. Can you tell me what 0.3 repeating is as a fraction? This is something you should know. Anybody?
1/3.
Right, 1/3. So basically this answer is 85 1/3 times. While we're at it, what's 0.6 repeating?
2/3.
Excellent. Yeah, these are 2 pieces of information you should have memorized from now until forever. Okay, so 85 1/3 times per second. Any questions on that example? All right. Third type of variation is called joint variation. Its general form looks like this. Y equals KX W, we'll say. Basically, well, Do any of you have a joint checking account? Or maybe you don't, do you even have a checking account? A joint checking account, I'm married, my wife and I have a joint checking account. That means there's more than one person on that account. Joint variation means there's more than one variable on the right side of the equation. So y equals k xw, for instance. Okay, so x and w, two different variables. Joint variation. All right, let's take a look at an example of joint variation. It says oil storage. The number of gallons of oil that can be stored in a cylindrical tank varies jointly as the height of the tank and the square of the radius of its base. The variation constant is 23.5. Oh, so in this problem, not only do they mention it, they tell us what it is. Find the number of gallons that can be stored in the cylindrical tank shown, and I'll be drawing a picture here in a minute. Okay, let's go back. The number of gallons of oil that can be stored in a cylindrical tank. So we're going to let G equal number of gallons stored. Okay. Varies jointly as the height of the tank. So H is going to be the height of tank, and the square of the radius of its base. R is going to be radius of base. And it says the constant of proportionality, or the variation constant, is 23.5. Okay, so our equation, the number of gallons, G, equals K times, see, varies jointly as the height of the tank, so H, and the square of the radius. So we get G equals KHR squared. Okay. Now, I'll draw a picture of the tank that has some information listed in it. And it says, let's see, from here to here is 20 feet. And from here to here is 15 feet. All right. So we're trying to determine the number of gallons, which is G. That equals K, 23.5 times H. Based on the drawing, what is the height of the tank? Is my drawing that bad? What would the height of the tank be?
20.
20. Okay, now be careful. What's the radius of the base?
$7.5.
Right, half of the distance. The 15 feet is the diameter, right? So all the way across is 15 feet. The radius would be half of that, or 7.5. Now, don't forget this is squared. Okay, so once again, calculator, G equals, let's see here, 23.5 times 20 times 7.5 squared, and I get, let's see here, 26,437.5 gallons. So the number of gallons that could be contained in that tank is that number. Any question on that? All right. So we've got direct variation, y equals kx, inverse variation, y equals k over x, joint variation, y equals kxw. All right. Now let's go through, and I'm going to read a sentence and then we'll translate it into a formula. It says A varies directly as the square of P. So A varies directly as the square of P. Don't forget K. All right. T varies directly as S. T varies directly as S. Z varies inversely as the cube of T. Z varies inversely as the cube of T. All right. Any questions? C varies jointly as X, Y, and Z. C varies jointly as X, Y, and Z. P varies directly as the square of A and inversely as the cube of J. So we've got two different kinds of variation in the same formula. P, don't forget K, varies directly as the square of A and inversely as the cube of J. So again, we can have more than one kind of variation in the same problem. All right, now let's go the other direction. Let's take some formulas and describe them in words. R equals KT, we would say R varies directly as T. Let's see. A equals K R cubed. We'd say A varies directly as the cube. Come on here. As the cube of R. Okay. Let's see. B equals K over H. B varies inversely as H. How about this one? P equals Km over N. We would say P varies directly as M, oops, and inversely as, oops, as N. All righty, any questions on that? So you're going to want to have the three kinds of variation memorized in terms of how those formulas are set up. Okay, so you know what to do with them. Anyway, that's all I have for you today. So tonight's homework, section 8.9, and the chapter review. Tomorrow, I'll be back today at 1:15 for an office hour. If you have any questions then. Tomorrow, we'll review for the test, and then the test is due by Monday night at 11:59 p.m. Anyway, have a great rest of the day, and I will see you later.
Good day.
Okay, thank you.